Welcome back to Huawei Routing and Switching Elite Training. Today topic we are going to discuss on STP Spanning Tree Protocol. Let's start our part 3.
Now in Huawei, by default, we don't need to use STP. The default is using MSTP. So under the MSTP port status, we have 3 status. It's discarding, learning, and forwarding. Okay, so discarding is where you have the port that is in alternate port. So it will be not forwarding. Alright, so it's called discarding. So learning is where you are going to learn the MAC address, but you are not forwarding the user traffic. And forwarding is the state where you can learn as well as sending, receiving BPDU. So this is the default in the Huawei switch. Now if you look into the port status transition, those with number 1, alright, you can see that from disable you go into the blocking. So this is where you start the switch. Is go into the initialization or when you enable the port. So number 1, you go to number 2, you can see that the blocking can go into the disable, alright, where you have the link failure. So when the link failure, it go back into the disable. So this is number 2. And from the forwarding, you also can go to the disable. So again, you have the port that is being failed or the port that is being blocked. Alright, so as you can see that from blocking, you may go into the listening. Okay, so listening is where you transition yourself from the blocking. Maybe you become the root port or you become the designated port. So once you are in listening after the timer expired, okay, which is about 15 seconds, then you go from a listening to learning and from learning to the forwarding. Now at any time the link fail, it will still go into the disable. Okay, so these are the port transition. Now so far we know that STP on the root bridge will send what we call the configure BPDU. Alright, now there's also another BPDU which is very important. It's called TCN BPDU. TCN stands for Topology Change Notification. Now the TCN BPDU are transmitted by each device to the upstream to notify the upstream of the change in the downstream topology. So in this case, the upstream is the root bridge. That is our reference point. Now once the root bridge being informed that there is a topology change, then it will going to send a topology change notification BPDU. Alright, so that the entire switch know that there is a topology change. But why that we need to be aware that there is a topology change? The reason is because that in our L2 switch, we have the MAC address table. The MAC address table contains the mapping on the interface with the MAC address, and typically the aging time for this will be about 300 seconds. Now if let's say they do have a topology change and you let them age accordingly, it will take long time before the topology can be forwarding again. So once the switch receive a TCN BPDU, it will age the MAC address table from normally 300 seconds and it will age it as a 15 seconds, so to expedite the forwarding. So the TCN BPDU is very important. So it is generated based on the following scenario. So firstly, TCN BPDU will be generated if the port is in forwarding state and at least one designated port reside on the device, and if a designated port receive TCN BPDU and send the copy of the root bridge, so which means that you actually do a forwarding. So here we have a bit 7 here. This is the topology change acknowledgement, and the bit 0 over here, this is the topology change flag. If let's say this is number 1, then we do have a topology change. So let's look into the topology now. Now here I have 4 switches. This is the root. So under normal circumstances, here I am doing the forwarding and here I have a blocking. Now for example, I have a failure on E1. Now since the E1 was a designated port and now the designated port is no longer available, the alternate port now will transition to a designated port. Now, once this is transition, a topology change is being sent. You can see that this is a TCN is being sent to the upstream toward to the root. Now, once the switch 2 receive this TCN, switch 2 is going to send an acknowledgement, okay, which is a topology change acknowledgement, and to tell the S4 saying that, hey, okay, I acknowledge that I received your topology change notification. Okay, so now stop sending the TCN to me. In return, S2 is going to send this topology change notification toward to the root. Now the root acknowledged the notification, and now it will going to send a topology change notification throughout the network. So once the topology change notification is being sent throughout the network, then the MAC address table will be etched accordingly. So the forwarding will be resumed. All right. Now let's just examine the convergence time of the 802.1d. Now here we have two scenarios. The first scenario here is where the root bridge itself failed. So when there is a root bridge failure, the convergence time would take about 50 seconds. The reason is because that you need to have the BPDU aging period, which is in this case is 20 seconds. All right, and we also need two times the forwarding delay, and each of the forward delay is 15, so it's 15 times 2. So altogether we have 20 seconds plus 30 seconds. That is 50 seconds if let's say there is a root failure. Now 50 seconds is really long time, so a root failure is not desirable. Now next here, if let's say the root is available, but what happens if let's say there is a link failure? When they detect a link failure, BPDU are still being sent. So this will be transition from a blocking to a forwarding, but again you still need to for a forward delay. Forward delay which is 15 seconds times by 2. So again you still need to wait for 30 seconds. Alright, so here we have two scenarios where there is a root bridge failure. It will cost you 50 seconds of outage, and if let's say there is a link failure, it will cost you 30 seconds of the outage. So that is the main limitation of a STP. So if you look into the STP here, port status or the port row are not distinguished in a fine granular manner. So which means that we have only a few port state. We need to have more. Second, the STP algorithm determines topology change after the time set by the timer. If you still remember just now the slide I told you about the forward delay as well as the max age timer, the maximum age is actually 20 seconds and the forward delay is 15 seconds. So that is really a very long time. So this actually make the network convergence very slow. And finally, STP is inapplicable to network with frequent topology changes. So if let's say your topology is not as reliable, and if assuming that your topology is changed many times during the day, then the STP may not be applicable for such an environment because there will be a disruption for your user. So next we are going to look into the alternative of STP, which is RSTP. Okay, so we already finished the STP. Now please remember that STP is something that you should aware of, but it's not really that important in your exam because this is considered quite old technology. So the newer technology will be on RSTP. So here we are going to look into basic concept of RSTP. RSTP stands for Rapid Spanning Tree Protocol. So we look into the convergence of the fast conversion of RSTP and how the RSTP topology change mechanism take place and how we can interoperate between RSTP and STP. Okay, right. Now the first thing here is that the RSTP is more superior because it defines more port, alright, as compared to the normal STP. And there are certain port status that is not really important. So in RSTP we have removed some of the port status. Now if you still remember on the STP we only have TC and the TCA, which is the topology change acknowledgement and the topology change, and that is only on the bit 0 and bit 7. But in the RSTP, we fully use all the flag in the BPDU. And the way that they process the BPDU are different. We are going to look into that. It really accelerates the convergence because of the way that they actually process it and the mechanic on how the RSTP work, as well as they add additional protection on the STP. Now firstly, let's look into the port role. Now in RSTP, we have the root port, designated port, alternate port, and something that you do not have in STP is called backup port. So here we have a more detailed port role. So here I have the root bridge. So the root bridge, as usual, we still have the designated port. And because that I have a triangle topology here, this will become my alternate port. Alternate port will be in blocking, or in this case discarding. But what you notice over here, this is a new port status. This is a backup port. Okay, so this is a new port that's available in RSTP. Now RSTP and the STP difference also in the port status. You notice that the port status on RSTP, we only have 3 status, which is forwarding, learning, and discarding. So here on STP, we have this disable, blocking, and listening. Now they combine into one status called discarding. Learning is still available and forwarding is still available. And only in forwarding, you can see that we do learn the MAC address, we do send and receive the BPDU as well as we forward. So the learning, as is earlier on, the status is the same, except that on the discarding, you notice that we do not send anything, we do not learn anything, except that if let's say the status is learning, we do send the BPDU. Okay, so these are the difference between STP and RSTP in terms of port status. Next, if you notice that on the RSTP, this is the bit that we have. Now early on in STP, we have bit number 0. This is still remain as the TC, and bit number 7 is remain as the TCA, so that RSTP is backward compatible. So port role are determined based on the flag. So we have bit number 0 all the way to bit number 7. So the value type is number 2. The 6 bit in the middle of the origin flag are reserved. Okay, so here we have the agreement, forwarding, learning, and this is a port role. So the port role over here, we have 2 bit. So if it's 0 0 means unknown, 0 1 means root, 1 0 means alternate or backup, and 1 1 mean alternate designated port. Alright, so this is the bit on the RSTP. Another major difference between the legacy STP and the RSTP, or rapid spanning tree, is how the RSTP process BPDU differently. Now first one here, a non-root bridge send a configuration BPDU from a designated port at interval set by hello timer. Okay, so we know that only root bridge in STP send the BPDU, but in the RSTP, a non-root bridge do send configuration BPDU at the interval set at the hello timer. Okay, and second, the timeout interval for BPDU is 3 consecutive intervals set by the hello timer. So it's different compared to what we have in STP, because we have a forward delay of 15 seconds and the max H timer of 20 seconds. And lastly, the block port can immediately respond to receive BPDU with a lower priority. So that is the key rapid what we call the convergence of the RSTP. So you can see that even if, let's say now I am a non-root bridge, as you can see that 4096, so I'll send this as a root, alright, because there is a link failure. Immediately I say that I'm the root. So S3 or switch 3 responded to say that, hey, I am 4096, you are 8192, so I will become the root. So here now the path will be in forwarding. So that is the difference, the first difference on the RSTP. Now, beside the BPDU processing on RSTP are different compared to STP, the way that the RSTP make the conversion faster, they have their own technique. Now, let's look into the revision here. STP conversion is actually based on the timer. Alright, the timer here is a forwarding delay of 15 seconds, and typically you need to have two forwarding delay because one is a learning and the other one listening, and the other one is a learning before they go into the forwarding. Now, different compared to STP, RSTP have a fast convergence. The way that they make it fast is that firstly they are using what we call the H-port. Next, they are using what we call the fast switching of the root port, and finally they use the proposal agreement mechanism. Now let's look into one by one in order on how this fast convergence can be achieved. Now let's look into the H port first. Now H ports are directly connected to a terminal. So those switch that connecting to a terminal, in this case it can be a PC or it can be a device, or in this case is a end device, then we call this as a terminal. So those we can configure as a H port. So what so special about the H port? If you configure the port as a H port, the port will able to enter into the forwarding state directly without any delay, okay, which does not trigger topology change. Now this is important because that if let's say they do have a topology change, remember that TCN will actually trigger the what we call the clearing of the MAC address table or CAM table. So if you have configured the port as an H port, then not only that, once I plug in my terminal and I'm able to use it almost instantly, beside that, it doesn't trigger the topology change as well. So it's important for you to have the port configured as a H port. All right. Next, the H port, once it's receive a switch, for example, so I configure this as a H port. All right, and now I plug in a switch, and the switch send a BPDU. Now what will happen over here is once you plug in a switch to an H port, it will lose the H port advantage, so it become a common port and it will revert back into the normal trunk port or access port where the STP calculation need to be performed. So that is what we call the H port. All right. Now with the fast switching of the root, the forwarding will be almost immediate. So how this work? Now as you can see from here, S1 is the root. Now S2 and S3 is non-root, and here I have a alternate port. Now when the link of the here between S1 and S3 is failed, what will happen here is, alright, so you can see that it's failed. The port from your alternate port, it will transition, it become the root port immediately. So here, when the root port of a network bridge become faulty and enter into blocking port, which is just now here, the optimum alternate port is used as a new root port, this interface here. If the designated port of the remote device connected to the network bridge is still in forwarding state, the new root port directly enter into the forwarding. So the delay for you to go from the alternate port to the forwarding port is almost instantly. One of the key component difference STP compared to RSTP is the mechanic of the proposal and agreement. Alright, so we simply call P/A mechanism. So how this P/A mechanism work? Now let's say now I have this switch number 1 and switch number 2. Switch number 1 and switch number 2 are not connected. So right now switch number 2 have 3 ports. Port number 2 is in alternate port, port number 3 is in designated port, and port number 4 is an H port. Now since this is in the alternate port, we will not go into the calculation of STP, as well as the H port will not go into the calculation of the STP. So the one that will go into calculation STP is the designated port. Now we have a new switch S1 where we configure the priority to be very low, which in this case is a root connected to the S2. Now once this connection is established, S1 is sending the proposal to switch 2, including the priority. Now when S1 send the priority to S2, S2 is going to do a comparison and check that the proposal sent by S1 is better. In this case, the priority of S1 is better than itself. So what it will do here is that on the port number 2, from a designated port, it will transition to the block port. Okay, so here it will go into the block port, and then it's going to do a synchronization by sending an agreement to S1, agreeing that S1 is the root. So once the agreement is already done, so S1 and S2 is in sync. Okay, now if we proceed and we look into the this topology, now same thing. So this is my root. I'm actually connecting it. So now proposal is being sent, agreement is being received by S1. Now since this is a downstream, it will send, which is S2 is going to send this information downstream to itself. So it's going to send a proposal to S3 and S4. Now if S3 and S4 doesn't have any better cost or any better priority, it's going to agree on the proposal by sending the agreement back toward to the root. So now the whole topology is agreed that this is my reference point, which is this is my root. Now the proposal and agreement will make the convergence faster, and in theory this will be in a second or sub-second. Now let's look into the RSTP topology change, alright, or TC. Now the condition for the TC to generate is whether a non-H port change to forwarding state. So assuming that you are from blocking state to forwarding. Now the condition is that it have to be a non-H port, because when you are the H port, changing from a blocking port to forwarding port doesn't create the topology change notification. Okay, so please aware about that. So the processing of the topology change will be like this. First, it will going to send a reset BPDU with a TC field of 1 similar to STP to all designated port and to the root port at 2 intervals specified on the hello timer. So the hello timer by default is 2 seconds. So we have 2 times by 2, so equal to 4 seconds. Now once you receive this topology change notification, it will going to clear the MAC address entry learned by all the other non-H port except the port that received the RST BPDU. So this is the topology change on the RSTP. Now next we are going to examine the interoperability between RSTP and STP. So if I have 2 switches, one running on RSTP, another one running on STP, how they will be interoperate. Okay, now firstly, if a port on an RSTP capable device receive a configuration BPDU, so STP send a configuration BPDU to the RSTP, the port switch to the STP mode after 2 intervals specify the hello timer. So which means that here I may have RSTP, but here I'm going to change to STP after 4 seconds because it's 2 hello timer. Okay, and each hello timer is 2 seconds. Now second point here is when the port switch from RSTP to STP, definitely the features such as the fast conversion were lost. So we will go back into the forward delay of 20 seconds and the there is a max H time of 20 seconds and the 15 seconds of a forward delay. Alright, so we still have this in the RSTP configuration. And lastly, when STP capable device is removed from the network, so if this is removed, then what will happen here is this guy will return back into RSTP. It will go back into RSTP mode. Alright, so here we have the interoperability between RSTP and STP, so you do not need to worry if let's say you are going to mix these two together, but definitely in the network preferable to be all RSTP to take advantage of the fast convergence. Now in your exam, STP and RSTP is quite easy because there is only one command for you to change from STP to RSTP. So RSTP take advantage of the fast convergence, but basically the concept of choosing the root bridge, designated port, and the rest is the same. Okay.
Thanks for watching. Please do not forget to subscribe to our channel.